Ciao Gordon.
Ciao, ciao, ciao.
Vabbè,
Mi
adesso poi
senti?
siamo live, non siamo live? Non ancora.
Ok, un attimo. Allora, no, non abbiamo ancora incominciato. 2 secondi.
Sì, volevo solo salutarti, ho visto che
Ok, grazie.
oggi cominciamo 15 minuti più tardi.
Sì, c'è stato un inghippo.
Anch'io sono in ritardo con alcune cose, quindi mi è andato bene.
Ok, quello lo chiudo. Ok, 2 secondi e ci sono. 2 secondi. Quella è una bugia. Di sicuro. Allora, audio. Allora, l'audio out dovrebbe andare su. No, perché? Perché? Allora, audio in. Ma porti una miseria, non capisco un tubo qua. Allora, audio in dovrebbe essere questo. Quindi, nope. Ok, quello funziona. Audio out dovrebbe essere questo. Ok, ok, let's just see. Allora, Livio, can you just say something, please?
Ecco, prova, mi senti?
Yeah, can you just say something again, please? 1, 2, 3. Okay,
Prova.
fine.
1, 2,
No,
3.
fine.
A
Okay,
posto.
great. Thank you. It's because I'm just playing with the audio here, and it's a bit. I've got a I've got un giro, which is a little bit strange. Well, maybe it's not strange, but it's I'm not quite familiar with it yet. So I'm just going to wait about 5 minutes for the other people to join. 3 or 4 minutes just for the other people to join.
Yes, of course.
Now it says Gordon's Zoom meeting avvia, but you're already in it, so it should be all right. You just followed the link from the WhatsApp?
Yes.
Yeah. Okay. Fine. Okay. So while you're there and while there's no one else, can I just ask you to tell me, can you hear this? I'm just playing a video.
Resto visibile fino all'inizio della registrazione.
There are many different substances. Can you hear that? No. No. It's
almost no.
Almost no, because it's coming out of the television. It shouldn't be coming out of the television. It should be.
Scusa, tu vuoi far vedere o solo sentire?
No, era solo sentire.
Vorresti farci sentire qualcosa che hai sul tuo computer?
Sì.
Allora, forse tu hai un computer Windows o Mac?
No, è un Windows, è solo che sto usando un mixer virtuale.
Sì, è quello che volevo proprio chiederti, appunto, se bisogna...
Allora, input. Allora, where would that... okay, hold on a minute. Hello?
Sì, ti sento? Sento te.
Okay, yeah. It's me speaking. It's not the it's not the audio.
Perché praticamente adesso come input audio è microfono.
Esatto.
E invece tu dovresti mettere stereo mix.
Yes, it's just trying to understand, sto cercando di capire che giro fa questa queste cose che visualizza i video. Forse devo andare su preferenze e audio, eccoci. Allora, modalità di uscita, urca, no, porca miseria, all of that stuff, no, video, uscita, dispositivo, questo è troppo complicato. Hello. Dalla memoria audio sofà, audio finta. No. Proviamo. Just making up. No. It's not that. Well, I don't want to waste too much time trying to do this. So hello everybody, just a couple of seconds. It's we're waiting for a couple of other people to join, and there's just a couple of technical things which I'm trying to sort out here. Everything seems to have gone slightly wobbly at the last minute, so portate pazienza un attimino per favore e vediamo se riesco a... Allora, perché prima ha funzionato?
Ciao Gordon.
Hey, ciao Sal. How's things? You okay?
Okay.
Yeah?
Hopefully too.
Are you doing everything online now?
What? Is there a specific duty to do online?
No.
No. Okay, no.
Well, if you if you're not online, you're not online. Oh, it's okay.
Okay.
No, sorry. Okay, I'm just, as I say, I'm just waiting for a couple of people, and in the meantime, I am trying to work out what this damn thing could be. So it's not the webcams, it's not the droid cam. It can't be any of these other things. So where is it? Maybe it's the virtual input. And that should come from the VB audio. So this should disposizione audio. That's it. I think maybe, yes, this is the one. Maybe. Let's try this. Okay. Okay. Right. Can I just ask you guys, did you hear that? Some guy, yeah. It was me talking about a glass of water. Yes? L'avete sentito?
Yes.
Okay.
Yes.
No, now I understand. Ho capito la cosa. Oh, right. So who have we got today? We've got Stefano Corbello, which is me, but not really. We've got Livio, we've got Sal, we've got Alessandra. Hello, Alessandra. We've got Antonio, we've got Anna. I'm not sure whether we've got anybody else. Okay, Anna's switched her video off, which is okay, but... Hello, Anna. Are you okay?
Hello, Gordon. Yes, thanks.
How's things going?
Fine, thanks.
Yeah. Are you doing lots of online lessons?
Sorry?
Are you doing lots of online lessons?
Non ho capito. I don't understand.
Not school. Okay. Are you doing?
Yes.
Online lessons?
Yes.
Lots of them?
Yes. I did not every lesson. Not
Okay,
all
not
lesson.
every lesson. Okay.
No. I did, I think, 3.
Uh-huh. Okay. How many do you do today? How many do you do a day?
Last Tuesday,
Mm-hmm.
the 27th October,
Okay.
and the lesson before, no, I didn't.
Mm-hmm.
And the first lesson, I arrived on late.
Ah, it's okay. Don't worry. Don't worry. I don't. The real Stefano maybe worries about these things. I don't. Okay.
Okay.
Good. Okay. Ciao, Rosella. How's now microphone?
Oh yes. Hi.
How is Malta?
Oh, it's very, very warm
Yeah.
today. Yes.
Yeah. So yeah. Okay. So are you busy doing online stuff, or are you?
No, just I help my friends in I'm helping in a trasloco.
Trasloco, which is moving, isn't it? Moving house.
Moving.
Yeah, a house move.
They're moving. Yeah.
Okay. So they are moving
House,
house. Okay.
house moving.
Yeah.
House move.
Okay.
Okay.
Okay. Good. Antonio, have you had a good week?
Oh, yes. Yes. There is work to do, especially at school. Half of the and the other online. So
Okay. So half of it.
we need to divide.
Okay. So half of your classes are online. Half is at school.
Yeah.
Oh, that's a bit of a mess. Yeah. Okay. What about
very difficult to explain something. They can understand. They need to go to the toilet. They need to go to ask something.
Yeah, it's a bit difficult. Okay. I just wonder, Alessandra, how are you? Are you okay?
Yes, I'm okay. Thank you.
Are you doing online stuff now?
No.
No.
Only at school.
Only at
I
school.
work in primary school, so.
Okay. So you're working. Are you working with the younger kids?
Yeah.
Okay. Yeah. Okay. Now I remember. Okay. Good. Okay. Right. So hello again, everybody. A little bit later today. Sorry, the technical stuff was a bit. The other Stefano, the real Stefano, forgot to send the link, and I forgot to remind him. So, because I thought he did it automatically, but obviously he doesn't. So what we're going to talk about today is we're going to talk about properties of materials, or properties of matter, if you like. And so the property of this pen is that it doesn't work anymore. So that pen's going over the other side of the room. Properties of materials. Okay, so I think this is an interesting topic from a language point of view, because it's the basis of sort of helping us describe things. So we're describing, or we're providing description. Okay, so I think before we start to look at some of the materials that I've prepared, and again, I think I told you before that I'm using this as an opportunity to test some materials, and also test how I do stuff, because I think for me the online activities are going to become more important. So I'm using this as a practice, if you like. So with that said, I'd like to propose a little bit of a brainstorm. So if we think about properties of materials, can you think of some examples of properties? And maybe you don't know the English word, but maybe you've got some ideas in Italian. So if necessary, we can translate. Okay. So I want you to be thinking about objects, things, stuff, material, matter. Okay. So can you think of, Alessandra, can you think of a property or some properties of materials?
Material. It can be hard or soft.
Yeah. Okay.
Or,
okay. So that's good, because that's a nice pair. Okay. Yeah. Anna, have you got any ideas? Any thoughts? Microphone.
Eccomi. It can be, how do you say, strong, like
okay, yeah, you mean like the fact that it's like
yeah, yes.
Okay, so it could be strong.
And
what's the opposite of strong? Do you remember? Weak, yeah, good.
No. Okay.
Weak.
And also, if it can be more long, you know, how do you say?
Okay, so you've got longer or shorter, long, short. Yeah.
If you can transform.
Okay.
If it's possible to transform.
You mean like to stretch? Like
yes.
Yeah, I'm looking around.
See, stretch.
Yeah, so sort of pull things like this. Okay. Yeah. Okay. So, stretch. Stretchy. Okay. That's not a very scientific word, though. Can you think? Can anyone help with what the scientific word would be? Begins with E.
Elasticity.
Yeah, it is. It's okay. So elasticity is the property. Elastic is the elastic is the adjective. Okay. Yeah. Okay. So we've got something which is elastic. Okay. Sal. Sorry, I've just got a list of names here, so I'm just going up the list.
I'm thinking of thick and thin, maybe.
Okay. Thick and thin. Okay. Yeah. Okay. Good. Antonio. A property.
I think to density. For example, materials have density, so we need to
okay,
think.
So density is the property. So you talk about material being more dense or not dense. Okay. Yeah, that will be the opposite. Okay, because it's one of those odd words that doesn't have a true opposite. It's just an amount of density, whether it's highly dense or whether it's not dense at all. Okay, good. Anybody got any other properties that we might think of? Livio, I haven't asked Livio, and he joined early.
Compressible.
Okay, so you could say whether something you can compress it. Okay, so that's compression, compressible. Okay, compressibility. Okay,
Yes. And then a property could be conductivity of heat.
Okay.
Or
so we've got
conductive.
Yeah.
Or
Okay.
not
Conductivity.
conductive.
Okay, so it could be conductive. Or it isn't conductive. It doesn't conduct.
Transparent.
Ah, okay. Hold on a minute. Doesn't conduct. This is isolate. Isolante. Okay. On insulate. Sorry, no, it's not isolate. Sorry, it's insulate. Insulate. It's much more similar to the Latin. Okay, insulate. Okay. Sorry, someone just said
Transparent.
Transparent. Okay, so we've got transparency.
Transparent, yes.
Okay, transparent. What's the opposite of transparent? Anybody?
Opa.
Keep going.
Solid. No.
Oh no, opaque.
Opaque.
Yeah, opaque. Okay, opaco. Yeah, opaco. Ah, that's a good selection of stuff here. Right. What I'm going to do is I'm going to play a very, very short video. Okay. What I want you to listen out for is I want you to listen out for properties that are mentioned. Okay. Now, some of them we've mentioned. There are some different ones here. Okay. But what I'd like you to do is I'd like you to see how many properties you can come up with that are mentioned in the video. Is that okay? Yeah. So you might need a pen and a paper to do this little exercise. So if we just open that 2 seconds. Where is it? Where are you? Okay, you're opening here. Come on, up you come. Let's decide. Oops, no, I didn't want to do that. And I'm going to put this over here. Okay, and I can look at that. I will bring up this. Move that. No, I'll put it down the bottom because it's out of the way there for me, I think. Right, are you ready?
Oh, yes.
Yeah, okay, so I'll have to put the phones on so I can hear this. And pull up the mixer, and off we go. I can't hear anything. It's not working. Ah, here it is. Hold on. Okay, I'm going to try this again. Here we go.
Non sento niente.
Non si sente?
Io no.
No?
Ah, ok.
Non si sente?
Ancora solo.
Sentire no.
Ah, ok. Ho capito. Right. Okay, so it looks like the video for some reason the video output isn't working through the mixer. So I'll tell you what we'll do. I will read this. Okay, so it's just me anyway because it was just a recording of me. So here we go. So if you're ready, so here we go. So hold on a minute. No, not that one. Not
You
that one.
can unconnected your headphone. So
No, it's got nothing to do with it. It's not got.
No?
It's got nothing. No, it's got nothing to do with the headphones. It's because it's to do with the routing through the mixer. But it's because I've just opened a new program for the video, and it probably doesn't like it too much. So anyway, what I'll do is I'll go through the video, but I'll read it. Okay, I'll just try and remember to do it at the right speed. Okay, so here we go. Ready? So we're listening for properties of matter. Okay, see how many we can get. Okay, so there are many different substances making up the world around us. By observing and understanding their properties, we can improve them and create new materials. Which properties can a material have? A glass containing water is made of two substances, the glass and the water inside it. Assuming that the water is normal and there is nothing in the water, assuming that the glass is normal and there is nothing in the water, both are colorless. It is obvious that the glass is solid while the water is liquid. If we put the glass of water in the freezer for a few hours, we would notice that the water had become solid ice. Leaving the cold glass and ice at room temperature for an afternoon, we would see that the water becomes liquid again, while the glass remains unchanged. Assuming that the glass is absolutely normal, we can see through both it and the water. They are both transparent. If we bring a burning match close to them and place it on the surface of the water, it goes out. Clearly, neither the glass nor the water is flammable. The glass is hard while the water is soft. Being a liquid, it yields when we apply a force to it. The glass does not smell, and if the water is fresh, it does not smell either. If we put the glass and the water in a microwave oven, they get hot, and at some point the water boils if we heat it enough. If we place a piece of sodium metal in the water, we see a small orange flame and some bubbles as the metal reacts with the water. The glass remains the same. Similarly, if we put two copper electrodes into the water and attach them to a battery, we will soon see bubbles of gas at both electrodes as the water is split into oxygen and hydrogen. Again, the glass does not react. From this simple everyday example, we can see that each of these substances has a unique set of physical properties, including state, color, density, hardness, smell, and flammability, as well as chemical properties. Chemists try to find out why substances have such different properties and try to understand how they can use them and even modify them. Okay? Okay, so let me just get rid of that. So what which properties did you pick up on?
The glass is colorless, for example.
The glass, sorry?
Is colorless.
Okay, so the glass is colorless. So we've got colorless. So we've got colorless. We've got color. Okay. What else?
hardness.
Okay, yeah, we've got the hardness. The glass is hard, so we've got the hardness. Or softness.
Is a shape. It has a shape, particular shape.
Yes, yeah, okay. So in this case, it has a shape. Now, the glass compared to the water,
Yeah.
does the water have, there was a film, wasn't there, The Shape of Water? Is that right? There was a film called The Shape of Water.
The Shape of the Water is a famous novel of a Capri.
Yeah, it was a film. They made a film of it.
Yeah, yes. Montalbano.
What is The Shape of Water?
It can be a different shape.
It takes the shape of.
It depends on the container.
Yeah. Okay. I think was it Gloria? Were you saying it takes the shape of the container? So this is a typical property of liquids, and of course gases. Okay.
Yes.
So
yes.
Okay. Whereas, so we've got liquids, gases, and of course the glass is the opposite, which is a solid. So you've got solid, liquid, gas. So you've got state. Stato. Okay. So you've got solid, liquid, gas. Okay. Okay. Which other properties did I talk about briefly in the video?
Transparent, you said too.
Yeah, we talked about transparency. Now, there's something. Hold on, just 1 second. Transparency. Okay. Sorry, you then said?
Smell.
Someone said?
Water hasn't got smell. Doesn't smell.
Okay, so I also mentioned something about a smell, which might be a rather curious property to put in, but it is a property of it's actually a chemical property of a material, but it's still a potential property of a material. Okay, just coming back to transparency. What is the difference between colorless and transparency? Because this confuses many people.
Probably does colorless mean it has no color, while transparency means you can see through it?
Yeah, exactly. So I can sort of show you an example here. I won't tip this up. Actually, I'll tip this one up because this is, you can just about see the pen through this tube, okay? This is transparent, but it's yellow, okay? Yeah. This stuff, well, this is very pale yellow. It's almost colorless, but not quite. And I definitely don't want to pick that one, throw that one around. Okay, so yeah, so you've got a difference between colorless and transparency. And transparent, they're two different things. So you can have colored things which are transparent, and of course, the opposite we said was opaque. Okay, which other properties did we mention?
Unflammable. No.
And energy makers.
We talked about flammable. We talked about flames, didn't we, with the match, and the match burns but is extinguished by the water. Okay, so neither the water nor the glass are flammable. Okay, now I'm just going to introduce a sort of a curiosity, a linguistic curiosity more than anything. There is in English there are two words for something which will burn: flammable and inflammable. Okay, this is not the opposite of that. Okay, they both mean the same thing. Okay, which again sometimes confuses people because it's a bit strange, because usually when you have a prefix you negate or you change the meaning of the original word. For some reason, both exist in English, and they've persisted. Okay, so non-flammable. Okay, non-flammable would be a material which will not burn. Okay, now I think it was Ivo mentioned energy makers. Okay, so that would make me think of combustible or non-combustible. Okay, so this is something which will burn. This is something which won't burn, or which cannot be burned. Okay, so we've got those properties too. Other properties that were mentioned.
Also, boiling temperature is a property.
Yeah. Okay. So we said the boiling point. I don't know whether I named it as the boiling point, but yes, if you heat water, you reach 100 degrees, which is the boiling point. Okay.
The possibility to solve something in the water.
Okay. So this is
dissolving. Make a solution.
Dissolving to make a solution. Okay. Now, in this case, we talked about we talked about the glass. We talked about the water. I didn't specifically talk about this, but if we think about a material, we can say, does it dissolve?
Mm-hmm.
Okay, so can you make a solution? So is it, and the property is solubility, is it soluble? Okay, now something which is not soluble is
insoluble.
Yeah. Oh, these things, in the end, you just have to learn them because there's no rhyme or reason. Okay, they're insoluble. Okay, so is it soluble? Yes. Is it not? If it's not soluble, it's insoluble. Okay. The process is dissolution. Okay. Although typically people talk about dissolving, to dissolving things. Okay. Okay. So if we have a glass of water and we heat it to 100 degrees, the water will eventually evaporate.
Yes.
Okay. If we keep heating the glass, like we just
È bloccato.
Oh.
It's gone.
Gordon.
leave it.
Ecco.
Internet is not stable. Oh.
Yeah, you were off for a while.
Okay, and
we,
now
we left you with if we if we hit the glass.
Yeah.
say something?
Can you hear us?
Yes, I can now.
Yes.
Yeah, I think the for some reason the connection went down. I don't quite understand why.
Yeah.
Yeah, so sometimes it's not so stable for some reason. Okay, so okay, so you have a glass of water and you heat it. The water evaporates.
Yeah.
Okay. What happens if you keep heating the glass? Like big temperatures. What will happen? Does the glass stay the same?
It breaks.
Okay. Okay. So assuming that you kapang, okay.
It doesn't become a whiskey.
It doesn't become whiskey. No, that's true. Okay, assuming that you heat it up in a way that it doesn't actually physically break, what will happen to it if you just keep heating it?
It melts, no?
Yeah, it will melt. Okay, so you'll end up with okay, melted glass. Okay, or molten glass. Molten. Okay, so something which melts becomes molten. Okay. Yeah. Okay.
Gordon, sorry, I don't understand. Would you mind to repeat?
No, not at all. No problem. No problem. Okay. So, this bit's okay, yeah? So
I can't see.
Oh, you can't see. It's because I'm
Yeah.
not sharing anymore, am I? Scusatemi, potete anche dire qualcosa. Ok. Adesso, vedete? Can you see that?
Yes.
Now, yes.
We can.
Okay, right. Sorry about. I assumed that it had just redone everything, but of course it hadn't. Okay, so water, 100 degrees, it evaporates. Okay, that's easy enough. But I said, well, let's keep heating the glass. So you heat the glass. Now, I don't know what the melting temperature of glass is. It's probably what, 1800.
It's not a precise temperature.
No, it won't be. But it'll be. Is it above 1,000 degrees or something like that? I don't know. Someone can go on Google and look it up. Alessandra, can you find the melting temperature of glass on?
I
on
don't
Google?
know.
Oh, look it up. Look it up. You've got a
Okay.
phone.
I can find it.
Okay, right. Okay, so was it Gloria who asked about the thing? Okay, assuming that you heat it up in a way that it's not going to break, because this was it sort of going pang, okay, kapow, the glass will melt, okay, and it will just become a liquid. It will become liquid glass, okay, molten, yeah? Is that okay, Gloria?
For me now is okay. Thanks, Gordon.
Was it Anna? Sorry, it was Anna.
Yes.
Who
Yeah, I think, yeah, okay.
Excuse me, Gloria.
No problem.
I can't see. Zoom
Voices, our voices, I think they're pretty similar.
Yeah, you are pretty similar, although you have more of an American accent. No, it's just that Zoom does this stupid thing when I share the screen. What happens is I no longer see all of the faces, but I just see a strip, and it's like random people. So sorry about that. Okay, so just thinking about what else we had. We had transparency. What about reactivity? there was an example. The example.
Gordon, I remember when you put the gas in your car during the winter, people say, it's much more during the Easter or the summer because gas, for example, has a compressibility. So
right, okay. So first of all, hold on. I have to ask you a question. Are we when you say gas, are you talking about methane? Yes.
Methane.
Methane, metano.
Yes, yes.
Are you talking about the American gas, which is petrol, benzina?
No, methane.
Methane.
Is a proper gas. Yes.
Yes, it's bullshit. Because I'll tell you why. Because all of the methane has to be under pressure for you to get enough of it in your car to use as a fuel. Okay,
yes,
it's all a compressed system. Okay,
yes.
so the outside temperature makes very little difference. It's 20 degrees different. It's not going to make any difference because you have in una bomboletta.
Yes.
Yeah. Okay. Yes. So it's already under, was it 200 atmospheres, something like that? Okay. It's already heavily compressed. So that makes no difference.
This is a property of gas.
Yes. Yeah. Of course. I mean, compressibility, which I think maybe Antonio or Livio mentioned. Okay. This is a typical property of gases.
Yes.
Not so much of liquids. Okay, because of course this is the basis of hydraulics. Hydraulico. Okay,
yes.
hydraulic systems, which is a way of transferring force through a liquid to a distant place where where the force needs to be used. Okay, so yes, absolutely. What happens if you keep compressing a gas? It becomes a liquid. Okay, if you cool down a liquid, if you cool it down, you will get a solid at some point. Okay, that's temperature. Okay. Okay, so we have reactivity, we've got compressibility. Looking at the reactivity, the glass, is it very reactive?
No, of course.
No, not really. So if we just think about reactivity here, the glass isn't, sorry, but the water, well, the water is. Oops. Yeah. So I think the example that I gave in the short video was reaction with sodium.
Yes.
Yeah, sodium. Yeah. Which actually, while we're on this, let me see if it will actually let me do this.
Hydrolysis. No.
No. No, it's not. It's not a hydrolysis reaction because that's when you split something using water. It's hold on a minute. Let me just see if I can see if this will open, because I was just looking at this just the other day. There's a video that maybe I can show you. But yes, so sodium is here it is. Let's see if this will work. No, I think it's going to be too slow, maybe. Okay, well, anyway, so yeah, so sodium reacts with water, okay, in a very, let's say, vigorous.
Okay.
Vigorous way. Hold on. Hold on. Hold on. Why is that? Why is it doing that? Why is it doing that? Okay, right. Get down. Get down. Get down. Okay, right. Salto Nuncio. Sorry, I'm trying to find a place in a video which I wanted to. Dimmi.
It becomes so no. So not soluble or soluble.
Okay, yeah, okay. So we've got solubility.
Solubility.
Solubility. So that's something which is soluble. Soluble or insoluble. Okay. Now, what happens in the case of this is it's not really soluble. Okay, so it's not really soluble, but it is reactive. So it stays on the surface of the water, and the chemical reaction is sort of happening here, and it can get quite vigorous. Now let me just see if you can see this. I just wanted to. Oops, it's being a little bit jerky today for some reason. Okay, here we go. You won't be able to hear it, but you'll be able to see it. Can you see this? This is lithium. This is sodium reacting with water. This is potassium. This is rubidium. Okay. Now these are all elements which are sort of similar to sodium. It's just that they get more and more reactive. And then the last one, he just explains a little bit that this is a particularly vigorous reaction. This is cesium. This is the okay. So that's reactions with water. Okay. So this is not unreactive. Sorry, unreactive. Whereas this is reactive. Okay. Yeah. Were there any other things that we sort of mentioned, or that were mentioned? What about the electricity? What about the electricity? Do you remember this one?
Pure water is not conductive.
Yeah, it's a very bad conductor. Yeah, it's a very, very bad conductor. But if you put a little bit of salt in it, or, well, rather than salt, something like sodium sulfate, because that just helps with the conduction. Okay, so you get, it's conductive. So it conducts electricity. Okay, it conducts current. Okay, this stuff, for those of you who are not so familiar with the chemistry, you just need a little bit so that you've got sodium plus and sulfate in here. This helps the water conduct the electricity. Okay, it's not for any other reason. If you're going to do this, don't use NaCl. Don't use that. It does work, but you don't want to be around. You don't want to be around one of the electrodes, because it produces chlorine gas, which is not a great thing to have around in your kitchen. Okay, so yeah, so we've got all of these different properties. Now there is one property which I can't remember who it was mentioned right at the beginning. Density. Okay. And that's what I'd like to talk about a little bit today. Let me just get the file open. Let's just get rid of that. And let's open this one. Let's open this one. See if this will work. And okay, right. Let's see if this works. It should present. Yes, it does work actually. Okay, good. Okay, so right. I don't know whether you've ever done this, but this is quite a cool experiment to do with kids. If you take 2 cans of Coke or Fanta, and you take one which is the normal drink, and then you take the other which is the diet version, they have slightly different recipes, of course, because the diet version doesn't have the sugar. It will have aspartame or some such sweetener. Okay, but this has an interesting property in terms of their behavior when you put them in water, because the cans are the same, but of course, because we have different masses, they behave differently. So if you put them in water, what would happen? What's the prediction? Anybody?
Maybe,
sorry.
maybe the molecules of, let's say, artificial sweeteners are weight more than sugar.
Than the sugar? Mm-hmm.
Or less. I don't know. Maybe more.
Okay. Okay. Let me just think. Aspartame is fairly similar to sucrose, okay, which is normal sugar. Sucrose has a mass of around about 280 or something, and I think aspartame is not too far away. It's not like massively different.
Mm-hmm.
Okay. Also, remember that in your normal container you have something like 35 grams of sugar, whereas the aspartame, you don't have 35 grams of aspartame.
Mm-hmm.
Because it's so sweet, you don't need very much of it. That's the whole point of them. Okay.
So the diet version should be should have a smaller density than the normal version.
Okay. So Olivia, what's your prediction then?
That I changed my prediction, saying that the diet version could be could have a smaller density.
Okay.
Because to have the same sensation of sweetness,
Mm-hmm.
you need less, a smaller quantity of artificial sweeteners than sugar.
Okay. Okay, so if I understand you correctly, this is what you're saying, that the density of the diet version will be less than the density of the normal version. Yes?
Yes, maybe. Yes.
Okay, and so when I put these into a tank of water like here, what do you think will happen?
They are no more fizzy.
No, they are fizzy because I haven't opened the cans. Okay, it's all still in the can. Okay, so if I poured them into the water, of course, that would be a different thing. But no, the cans are still the cans. Okay, what do you think would happen to them?
I think they both go to the bottom because there is the aluminum can and sweeteners. So the total density should be higher than waters.
Okay, so
Maybe,
but you,
but
okay.
maybe the normal version will go more quickly to the bottom.
Okay, that's very subtle. That's very subtle. So you'd have to watch it over time and see whether the normal version gradually sank and the diet version sank a little bit less quickly.
Mm-hmm.
Yeah. Oh, okay. That's very interesting. Someone else comments on what Livio has quite clearly described here. Does anyone have any objections or any comments? Rosella, what do you think?
I don't know. Probably the diet can float, and the other normal sank.
Okay, right, good. Well, thank you for bringing out the vocabulary. Okay, so to float is to stay on the surface of the of a liquid. To sink, obviously, is to go to the bottom. Okay, so you can say, well, you know, maybe the diet can will float, maybe the normal can will sink, maybe they will both float. Okay, I'm going to ask Ivo, what do you think?
I don't know, because I need to taste both of them.
Can you tell the difference?
No.
Can you tell the difference? That's the thing. Okay, well, Livio is actually sort of on the right lines, but it's actually a bit more dramatic. And unfortunately, I didn't have a chance to go to the supermarket and do this, but it's a simple experiment that you can do at home. All you need is, or you do in class, all you need is a couple of cans, and you don't even have to open them. Just put them in the water, and it does what it does. It's actually quite dramatic. And it's not a case of the normal one sinking, because there is enough difference in the mass. Okay, so I think the total masses. Let me just have a look here. I seem to remember writing them down. Yeah, the total mass of the normal version is 400 grams approximately, of which around about 8% of that is sugar, whereas the diet version is about 360 grams. So there's enough difference in the mass. The aluminium is the same because it's just cans. Okay, all they do is they change the labels. They don't change the cans. Okay, all of the rest is all the same. And so it really is. It's the amount of stuff you've got in the can, and that is enough to create a difference, which manifests itself in this let's say result of the normal can sinking to the bottom of the bucket, or to the bath, or to the aquarium, wherever you happen to do this. Of course, probably the fish don't really look like that at all, but anyway. Okay, so we could say that the diet Coke, let's say, is less dense. Okay, we can say that normal Coke is more dense. So basically, all we need here It's just the less and more qualifier, okay? We don't even have to think about denser, densest, or what have you. Of course, we can use superlatives, comparatives and superlatives. We can talk about uranium is more dense than lithium. Why not? Okay, let me just open this up so we can see it. You could say, so that you could also say it's denser than. Either of these work, okay? And you could say, well, osmium is the densest element, or the densest. In the periodic table, okay? So, and while we're on the subject of smell, osmium, the name, comes from Greek, meaning smell, apparently, because even though it is a metal, it has a rather unpleasant, it's actually quite toxic, a rather unpleasant odor. Okay. Okay. So if we look at this, we've got these sort of situations. If we look at the first situation here, which is the densest material? Which is the least dense? How can you tell?
B.
Okay,
B.
so B is the
Densest.
It's the densest, okay? B is the densest material. Why? How can you tell?
Because it sinks. It
Yeah.
sinks.
Yeah, it sinks. Yeah, it sinks. Okay.
I was thinking. I was looking for the past tense of sinking.
Okay. Well, the thing is no, but the thing no, it's a good point, Livio, because the thing is that since it's a property of the thing, we can just use the present. It doesn't matter.
Yes, because always sinks. Yeah.
Yeah, exactly. It always sinks, unless, of course, you have to specify the liquid. If this were mercury at room temperature, it will be a different thing. Okay, but leaving aside those sort of subtleties, yeah, it's always it's a fact. Okay, so it's always going to sink. So we can just use the present. It's easy. Okay, if you decide to talk about battleships, okay, you could say that the Bismarck was sunk in the North, or the Bismarck sank in the North Atlantic. So you've got sink, sank, sunk. Okay, which for those of you who are into opera, sing, sang, sung. And for those of you who know German, singen, sange, gesungen. Okay, so these are the Nordic. This is the Germanic roots coming out here. That sink, sank, sunk. Okay, right. Okay, that's okay. Right. I wanted to actually, since I've got this here, and it took me. I was playing with this morning, trying to get it to work. And it was something that I wanted to sort of demonstrate to you. Now, can you see my hand there? Yes, okay. Since I've got it here, and we've only got a few minutes left, I just wanted to see whether I could actually get this to work. What I've got is, this is a sugar solution, okay? I've colored it yellow, even though it's not a very strong color. this sugar solution is actually very, very, very thick. It's about, oops, yeah. It's about 1-to-1 sugar and water. Okay, so it's really quite dense. Okay, it could be a little bit more, but now what I've got here, let's see if we can do it here. I'm watching my, this is water, and I don't know whether you've ever done this type of thing, but this is something that you can do again with stuff that you find around the kitchen. You just have to be a little bit gentle with this. You can make a, yeah. If you've got the patience, you can do this with lots of different liquids, and you color them differently and what have you. Okay, so this is water. Okay, so you can see that all I've done is I've now got 2 layers, but you can take it a little bit further than that. Okay, I have to be really careful with this one because it's not dangerous, it's just messy. This is kitchen oil. This is sunflower oil. Okay, so I'm just going to put this on here, and that will definitely, because of the molecules, the way the molecules are, that will definitely not mix with the water. So we can sort of see this. Okay. Go. Via. Schifo. Okay. So now we've now got a a density column, but it doesn't finish there. Of course, you can sort of play with this as much as you like. If you have enough patience, you can make different densities of sugar solution. Okay, because sugar, you can actually get really quite dense solutions. This is alcohol. This is just the cleaning alcohol. There we go. Okay, so if you feel like it, you can make a rainbow. And this sort of illustrates. It's a good illustration of how the different densities can be kept separate. And the only difference between the yellow and the red, these first two, is the fact that this has a lot of sugar in it. Okay, you can do the same with salt. Okay, now the difference obviously between the water and the oil, there's also a physical chemical difference, which is in the properties of the material. Okay, this is hydrophobic, this is obviously hydrophilic because it's water. The alcohol is obviously lighter than the water, but it's very miscible with the water. So if you put the alcohol with the water, what you'd find, it'd be very, very difficult for you to get the two to stay separate. Okay, but it's a lot lighter than the oil. Okay, so this is a little density column. So I just thought I'd show that while I've got the stuff here. So as I say, it's something that you might want to look into that sometimes, maybe. And you can do it very easily with stuff that you find in the kitchen. There's nothing particularly difficult there. Okay, right. Another type of experiment that you can do with density is measuring the density of materials like plastic and metal and stuff. How do you measure the density of something? So that's quite, that could be an interesting question for people. How do you measure the density of something?
Density, we should answer?
Mm-hmm.
Should we answer to the question?
Yeah, yeah.
Density is the ratio between mass and volume. So you have to divide the mass
Yeah.
per,
Okay. Good.
per,
Divide.
per the
Fratto.
volume.
Mm-hmm. Yeah. Okay. And so this is divide by. So this is the mass divided by. Now there is another way of describing this. You can say this is mass over volume.
Mm-hmm.
Okay. Just for those of you who might want to be able to sort of talk about a formula. Okay. This is a nice simple formula. Okay. So what do we need to measure the mass?
You can put it in a glass of water.
And then I've got a wet object.
And
then poi è bagnato.
yeah. But
Excuse
if
me.
it floats.
Okay. Oh, now the thing is, if you're going to do it that way, that gets very complicated. Okay?
Yeah.
This is because you need to know about densities of liquids and stuff, and
You can use a scale.
yeah. So very, very simply, use a balance. Okay. Balance. Okay. It doesn't have to be an analytical balance. It could be something fairly simple, but a balance. Okay. But what about the volume? How can we measure the volume?
It depends by shape.
Yeah. Okay. So it will depend on the shape. Yeah. Okay. Depends on the shape. So if you have something easy like a regular cylinder, what can you do? Let's say you've got something which is nice and regular. What can you do?
The formula for the volume is the area of the circle.
Okay, so it's the area of the circle by
the height.
By the height, okay, or the length. Okay, so basically what you're telling me is this situation here. You basically measure it. Okay, so you can use a ruler or use whatever, so you can measure it. Okay. An alternative, so this is measure then calculate. Okay. The alternative is the situation that we've got here, which is sort of, I'm not sure whether you were actually thinking of this. Maybe because this is the classical way of, if you have an irregular object, okay, irregular, and of course you immerse it in water. Archimedes' principle is that it will displace an amount of water equal to its volume, and so you just measure you can measure it directly. This is probably more accurate because you can use micrometers and all sorts of stuff, but you need the formula. This is more direct because you can measure it directly. Okay, so yeah, so this is a very simple, let's say, very simple experiment that can be done. You don't need very sophisticated equipment, and if you're into it, you can do some drawing. You can draw a graph, because one of the things which happens is you may have you may have different size pieces. And so what you can do is you can, rather than sort of just measuring it once, you should measure it many times. And if you draw a graph of the mass against the volume, the gradient is the density. Okay, and so this, by looking at these graphs, you can see immediately which is the most dense material. It's the steel. Which is the least dense? It's the PVC. Okay, so this is a simple, relatively simple experiment that you can do with. Okay, and this is the density column that you can do with students in class. It doesn't need a lot. It doesn't really need a lot of equipment. Okay. Right. So it's 6 o'clock. I have to hand this over to the real Stefano now, because I use his account to do these lessons. So, any questions? Any questions? No. Thank you for your patience with the various technical stuff. As I say, I'm still trying to work it out properly. But any comments?
Just a question about density and viscosity, because in Italian is very common to use the word denso, meaning viscoso.
Yes.
For liquids. So just like to know if in English is the same.
I think, right, okay, this is a typical...
So like oil is more dense than water, meaning it's more viscous, or in English?
No, I think I understand what you mean, Livio. It's one of those things, it's one of those terms which is used in common language, but
yes,
it's not used in a very scientific way.
Yes, of course.
So I'm just trying to think about, would I hear someone talking about something as being oh yeah, that's a really dense liquid? No, I think you're right. Actually, people would sort of would associate the thick oil with
thick.
They wouldn't say, oh yeah, oh it's really it's got a really high viscosity constant. You know,
yes.
They wouldn't, you know, they say, oh, it's really dense, but what they actually mean is that it doesn't flow. Yeah. So I think you're right. People would do that, and they do mix the two up. But of course, the two things are completely different.
Yes, but also in English,
I think
could say oil is more dense than water, meaning that it's more thick, more viscous.
I think sometimes people, I think, will say that. I'm fairly certain, because it's one of those things where the scientific language, the real meaning, the scientific meaning, doesn't get through in the normal language.
Yeah. Thank you.
Okay, no, it's good. It's good comment. It's an interesting comment. Anybody else?
The layers, different layers in the pipe was real impressive.
No, Sal. If you can go and do this in your kitchen now, if you feel motivated to do it. No, and I tell you, it's what is very interesting though. Well, very is a big word. If you do the sugar one. If you do the sugar one and you make the sugar really sort of the sugar solution quite thick, and you color the sugar with one color, and then you color the water with the other, and leave it for a few days, you will start to see diffusion. Okay, well, of course, because diffusion is going to happen. It's just that because of it's the viscosity of the sugar solution, and if you don't shake it, it will ultimately equilibrate, but it does take quite a while. It does take quite an amount of time.
So the trick will disappear.
Yeah, I mean, if you shake it, if I shook this now, it would be a mess. But if you shake it, if you shake the sugar and the water, they will obviously mix. Having said that, if the sugar solution is really, really concentrated, you've really got to shake it quite a bit to get it to mix properly. And you can see the you know, when you have a thick solution of something, you see that, and it's mixing with something which is not as viscous. You can see the lines. You can see this very easily with a sugar solution. But this, yeah, you can make a rainbow. Kids love it.
Nice. Thank you.
Okay.
Thank you.
Thank you.
Okay. Hopefully next time we're not going to be late in starting. We'll start at and I'll make sure that Stefano sends out the message automatically. Okay. And we're going to do a little bit more about this stuff, and then I think we're going to do something about optics, if I remember correctly. So, okay.
Okay.
Thank you.
Bye.
Thank you, everybody. Thank you.
Thank you. Bye.
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 Bye. Bye. Ciao.